finish that off. Okay, so we look at the examples in exercise 4.6.2. Okay, we have the first one is 4.6.2. Now with the first one, we are told that a minus 2 and then a plus 5 is less than or equal to 0. Usually the first thing we would have to do when we're given a quadratic inequality to solve is to factorize it. This one is already factorized, so we can skip that step. The second thing we would have to do is to find the critical points. So we find our critical points. Now the critical points are the values of a that make your brackets equal to 0. So you just say a minus 2 is equal to 0. So this means that a is equal to 2. And for the second one, a plus 5 is equal to 0, which means that a is equal to negative 5. Then what these critical points do, or why they're important, is because they tell you how to divide your number line. Okay, so you draw a number line like that, and then you put your critical points on the number line. They must be in the correct order. So we know that negative 5 comes before positive 2. Then from your number line, you create a table like this. And then you put your factors. The first factor is a minus 2. The second one is a plus 5. Then you made a table. So you make you draw a number line. From the number line, you extend it with the factors, with the critical points, and then you fill in the factors. Then what I say to do is you must pick a representative, just like a person who speaks for that region. That's what that number does. So make sure the number you pick is indeed in that region, otherwise it does not represent the region. So in the first one over here, we're looking for numbers that are less than negative 5. So an example of that is negative 10. And then in the next region, we're looking for numbers that are between negative 5 and 2. 0 is an example of such a number. Then in the next region, we're looking for a number that is greater than 2. So 4 is an example of such a number. Then what you do with each of those numbers is that you will substitute them into the factors, and then you're not interested in the values, you're interested in the sign of what you get. So whether you get minus 100 or minus 50, minus 1000, it doesn't matter. What I'm interested in is it positive or is it negative? So I start here with the negative 10. I substitute it there. So I have negative 10 minus 2, that is negative 12. So my answer is negative. Then I do the same thing, negative 10 plus 5. This is negative. And then I move on to the second column. In the second column, I have 0. So substituting it into the first factor, I have 0 minus 2, which is negative. And then the second factor, 0 plus 5, this is positive. Then the last column, I have 4 minus 2, this is positive. And then 4 plus 5, this is also positive. Then the last row, I go back to my factors. My factors were multiplying. So the last row, I'm also going to multiply the factors. So I put a minus 2 times a plus 5. Then I'm going to multiply the signs. So I take that sign there and this one over here, and I multiply them. Same thing here, this sign, that sign, I multiply them. This sign and that sign, I multiply them. And I'm also interested in the signs, not in the values. So when I multiply, I have negative and negative, it gives me positive. Then in the second column, I have negative and positive, this gives me negative. And then in the third column, I have positive and positive. This gives me positive. Okay. Then I go back to the question. The question was this one over here. I was multiplying my factors, and we said we want to know when is the product less than or equal to 0. So I'll rewrite it here. The original question was a minus 2 multiplied by a plus 5 less than or equal to 0. So you now refer to your table. So you look on the left hand side, you have a minus 2 times a plus 2 on the table. That is in the first column, the last row. Then you look at the values of the product. In the first column, the product is positive. That's not what we want. We want it to be less than or equal to 0. So less than or equal to 0 means negative. And then you go to the second column. What you do is you say this is negative and it satisfies what I'm looking for. So I want the product over here to be negative. So this column I'm going to tick it because that is a solution. So you tick it and then you move on to the next column. Here when I multiply them, the product is positive. That's not what I want. So it's not a solution. So after you've gone through all the columns, you look at the ones with the ticks. Here there's only one with the tick. There's only one with a tick, so there's only one column with a solution. So that means your solution comes from the column that has a tick, which is from minus 5 to 2. So this means your solution will be minus 5. Less than or equal to, I put less than or equal to because in the question it was less than or equal to x, and this is less than or equal to 2. So any number that is less than or equal to, if x is between minus 5 and 2, then it will satisfy your solution. Then you can also draw this on your number line to represent it. This is your number line. And then put minus 5 here, and you put 2 there. Then we said we put the shaded circle, and then we connect the points like that. That's how we would solve this one. Okay, so it's very simple. All you have to do, factorize. If it is not factorized already, find your critical points. Those critical points, they're important because they divide the number line. And then you find a representative in each of the regions. Then you solve depending on the original question. So the answer is not always the one in the middle, okay, or the one on the outside. It's not. It is the one that satisfies the equation. Let's look at another example.
Baris.
Yes. You're breaking up. I can't hear you.
The first is less than or equal to A.
Can you say that again? I didn't hear you.
Why
Were breaking up.
we say negative 5 is less than or equal to A?
Instead of x.
Why don't we say that negative 5 is less than or equal to A? Yeah.
Yes, it should
Why are
be.
we using X?
Why are we using x?
Yeah.
It should be A. It's not X. That was a mistake. It's supposed to be A because A is in the question. Okay, thank you for that. So that was a mistake. The question has A, so you must also use A. Then the next question, this one is number 3. We have 2x squared minus 7x plus 3. This is greater than 0. So remember, greater than 0 means you will look for the column where you have positive. Okay, so first thing we have to do is factorize if it is not factorized already. So you look for two numbers that when you multiply them, the answer is 2 times 3, which is 6. And when you add them, the answer is negative 7. So those two numbers are negative 6 and -1. So you open your brackets, this, you put your x, and then the two numbers, we say -6, -1, and then you divide by the coefficient of x squared, like that. Then you simplify your fractions as far as possible, and if it cannot be simplified, you bring the denominator over there. So this is what we have. Now it's factorized. Then what we do is we find the critical points. Now with our critical points, we said the first factor, x minus 3, is equal to 0. This means that x is equal to 3. And the second one, we have x minus 1 is equal to 0. This means that x is equal to a half. So these points, they tell me how to divide my number line. So I draw a number line like that. And then I put my critical points on the number line. So I have 3 here. No, sorry, not 3. I have half. And then I have 3. So the order that they come in should be the same as how they appear on the number line. Then I extend it to make a table. And then I put my factors, x minus 3, 2x minus 1. Then I pick a representative in each of the regions. So I start in this region over here. I'm looking for a number that is less than half. It doesn't matter, as long as it's less than half, it can be anything. So here I will pick 0. Then in this region over here, I'm looking for a number that is bigger than half, but less than 3. I can pick 1. Okay, so here, do this. So here I picked 0, and there I picked 1. And then in this region over here, I'm just looking for a number that is bigger than 3. And here I can pick 10. Okay, then what I do is all of these numbers that I have in red, I'm going to substitute them into my factors over there. And then I'm not interested in the value, whether you get 10 or 12, I'm interested in the sign of the value. So this is called a sign table. So I must have a table with signs only. So I substitute them and then I see what I get. If I substitute 0 into x minus 3, I get a negative answer. If I substitute 0 into 2x minus 1, I also get a negative answer. Then if I substitute 1 into x minus 3, I have 1 minus 3, that is negative. And then I have 2 times 1 minus 1, that's 2 minus 1, which is positive. And then 10 into the first one, 10 minus 3 is positive. And then 2 times 10 minus 1 is also positive. Then in the last column, I put the question as it was when it was factorized. So what do I have? I have a product. So I will put the product. So I have x minus 3, 2x minus 1. And then now I multiply what the factors were giving me. So the first factor here gave me negative. This one also gave me negative. When I multiply them, my answer should be positive. In the second column, the first factor gave me negative, second one gave me positive. The product is negative. In the third column, first factor gave me positive, second factor gave me negative. Sorry, gave me positive also, so the product is positive. Then I'm going to write down the question again. After I had factorized it, I had this. This was x minus 3, 2x minus 1. This is greater than 0. So when I had factorized it, there it is. This is what I have. Now, this is the row I am going to go to on my table. So you can see this first row is the row of x minus 3. The second row is the row of 2x minus 1. Then the last row, that is the row that I'm looking for. And in that row, I'm looking for the column that gives me a positive. Now, why am I saying positive? I'm saying positive because I want it to be greater than 0. Greater than 0 means it is positive. So when I look at my table, in the first column, it is positive. In the second column, this is negative. In the third column, this product over here is positive. So the columns that I want are the first one and the third one, because that is where it is positive. So it is this that I have over here that tells me whether I want positive or negative. I'm not saying the first column and the third column or the column in the middle. No, I look at what I have over here and then I decide, do I want it to be positive or negative? Greater than 0 is positive, less than 0 is negative. Okay, so I've said it's the first and the third column. So if it's in the first column, this means that x is less than a half. And then if it's in the third column, this means that x is greater than 3. So those are the possible solutions. If you pick a number that is less than half or a number that is greater than 3, you will see that the product of these two factors is also positive. And then try it. Pick a number between half and 3. Say 1. Substitute it in there. You will see that your answer is negative. Then you can also represent this on the number line. You put your 2 critical points and then a circle on top of the critical points. They are not shaded because this inequality does not have the equal to underneath. Then we say numbers that are less than half. So it's these ones going that way. And numbers that are bigger than 3, the numbers going that way. Okay, so this is one way to represent it, and then this is another way of representing it. You should be able to do it using both ways. Let's look at the next one. Number 5, we have 4 m minus 1. This is greater than or equal to m squared. So again, like a quadratic equation, you must bring everything to one side, 0 to the other side, but you always want the coefficient of m squared to be positive. So first you'll multiply out, you get 4m minus 4 is greater than or equal to m squared, and then these terms, you'll take them to that side because you want to keep the coefficient of m squared positive. If you bring m squared to the left hand side, then you will have negative m squared, and then you'll still have to divide by negative 1, and then your inequality will change directions. So when I do that, I have 0 will remain on this side, and then I have m squared minus 4m because I subtracted 4m on both sides, and then I add 4 on both sides. Okay, so this one here, I can just rewrite it. This is m squared minus 4m plus 4 is less than or equal to 0. If 0 is bigger than m squared minus 4m plus 4, it means that m squared minus 4m plus 4 is less than 0. That's what it means. Okay, then as usual, we factorize it. We look for two numbers that when you multiply them, the answer is 4, and when you add them, the answer is negative 4. So those two numbers are negative 2 and negative 2. So I put my m, then negative 2, negative 2, and you can see this is just m minus 2 squared. So this is just the same as m minus 2 squared. This is less than or equal to 0. Now we can still do it in the same way. So this is something for you to note. By the way, we still find our critical points. So our critical points, there is only one critical point because the critical point of this factor is the same as that one because they're the same. So we have m minus 2 is equal to 0, which means that m is equal to 2. So you do it in the same way. You draw your number line, and now you have only one critical point, so it divides the number line into two parts. So you can have several critical points. So even a cubic inequality, you will solve it in this way. You already know how to factorize a cubic inequality, except this time it will divide your number line into 4 parts. And you do the same thing. You pick a point in each of them, substitute, look at the sign, and multiply, and so on. So it's not just restricted to quadratic. Anyway, you pick a representative. You want a number that is less than 2, let's say 0, and then a number that is greater than 2, let's say 10. And then you put your factors, m minus 2, m minus 2. Then if you substitute 0 into the first factor, your answer is negative because it's 0 minus 2, which is negative. And then again, 0 minus 2 is negative. Then in the second column, you'll get positive, 10 minus 2 is positive, and also 10 minus 2 is positive. Then here we have m minus 2. This is squared. As I said, m minus 2 times m minus 2 is just the same as m minus 2 squared. So here I multiply negative and negative. I get positive, positive, and positive. I get positive. Now this is interesting in that there is nowhere that it is negative. This is positive, or it is 0 at 2. So if we're looking to solve this, m minus 2 squared is less than or equal to 0. We cannot get a negative value. The only possibility that will solve this inequality is when it is equal to 0. If we say we want to have this m minus 2 squared less than 0, this one has no solution. But then m minus 2 squared equal to 0, this one has a solution, and we can work it out. This is m minus 2 is equal to 0. This is just m is equal to 2. So this one is a little bit different, but we work it out in the same way, and we read it also from our table that here 0 at 2, that is the only place where you get 0, and therefore your solution is not an interval like with the others, but your solution is just a single point. Okay, let's look at number 6. Number 6 looks a little bit different, but the idea is exactly the same. Say this is greater than or equal to 2. Okay, now I think some of you will be tempted to multiply, so you'll want to do this. Say, oh, okay, I've seen questions like this before, so I'm just going to say 5x plus 1 is greater than or equal to 2x minus 2. You cannot do that. This is not correct. Now the reason you cannot do this is because when you're multiplying or dividing by a negative number, the inequality must change directions. Now you don't know whether this is positive or negative. So if you multiply it and you don't know whether it's positive or negative, you don't know if the sign should remain like that or it should change like that. So what you should rather do is this 2 that you have over here, you should take it to the other side. So what I will have is this. I have 5x plus 1 over x minus 2 minus 2. This is greater than or equal to 0. Here I have subtracted 2 on both sides, and remember we said that if we add or subtract anything on both sides, the inequality must remain the way it is. It only changes when we multiply or divide by a negative number. So here I've added or subtracted, added negative 2 or subtracted positive 2 on both sides. My inequality is still facing the same direction. So I have two fractions here. In order to add them, I must make the denominators the same. So I will have 5x plus 1 over x minus 2 minus 2x minus 2 over x minus 2. So you know how to make the denominators the same. You look for the lowest common multiple of the two denominators. So it's x minus 2 and 1, right? Then this 2, you will multiply the brackets out like that. So you'll have 5x plus 1 over x minus 2. Then this 2 here is negative. So let me rather make it one big fraction. So I'll make it one big fraction where I have x minus 2 as the common denominator. Then this negative 2 will multiply the x, you get negative 2x. And then the negative 2 again will multiply the negative 2 inside, and this time you get positive 4. Okay, so be careful when you're subtracting fractions that you do it correctly, and it must still be greater than or equal to 0. Then you combine your like terms, 5x and minus 2x. This gives me 3x. And then 1 and 4. This gives me 5. And then I have x minus 2. This is greater than or equal to 0. Okay, now what I do here is, instead of trying to make this linear, I should look at it as a quotient. So I'm going to find the critical point from the numerator, the critical point from the denominator, and then follow the same procedure, except in my final row, instead of having a product, see in my final row, the last row, I had a product over here. What I will do with this one, instead of having a product, I will have a quotient, because multiplying and dividing with positive and negative numbers, it still works the same way when you're dividing. So I find my critical points. So the numerator, I have 3x plus 5 is equal to 0. This means that x is equal to minus 5 over 3. And then the denominator, x minus 2 is equal to 0. This means that x is equal to 2. So I have my two critical points over here. I will follow the same procedure. They take my number line and they divide it into 3 parts. The first one is from minus infinity to 5 over 3, and then from minus 5 over 3 to 2, and then from 2 going on to infinity. And then from here, what I do is I extend my table, and then I put in my factors. So the first factor is the numerator, so I have 5x plus 1, and then the second factor is the denominator, which is x minus 2, and then my table. Then I need to pick a representative from each of the regions. So the first one, I must look for a number that is less than negative 5 over 3. Let's say minus 10. And then a number that is between minus 5 over 3 and 2. Let's say 0. And then a number that is bigger than 2. Let's say 1000. Why not? Then I substitute each of the numbers that are each of my representatives into the factors. So I'll substitute negative 10, write my answer there, whether it's positive or negative. 0 there, write my answer is a positive or negative, same thing over there. So doing that, for the first one, 5 times negative 10 plus 1, this is obviously negative. Then negative 10 minus 2 is also negative. In the second column, 0 plus 1, that is positive. 0 minus 2, that is negative. The third column, positive and positive. So I'm substituting each of these representatives. Okay, so always imagine the governor or some random person who speaks for the entire region. All right, then the last column, this time instead of writing the product, I will write the fraction the way it is. It was 5x plus 1 over x minus 2. But the procedure is the same. If I divide a negative with a negative, my answer should be positive. If I divide a positive with a negative, my answer will be negative. And if I divide a positive with a positive, my answer will be positive. So with the previous examples, I was multiplying, but the same applies here. Dividing two negative numbers gives a positive answer. Dividing a positive with a negative, you get a negative. Dividing two positives, you get a positive. Then go back, the original equation was, or after I had gotten 0 on the other side, this is what I have. And I say this must be greater than or equal to 0. So I ask myself, this greater than or equal to 0, what does this mean? When something is greater than or equal to 0, it means 0 or it must be positive. So I look for this one over here on my table, and then I see, oh, there it is. It's in the last row. Then I look for the column where it is positive, not the first one and the last one. That's not what I'm looking at. I'm looking for where it is positive. So this positive over here. So when I go to the first column, yes, that column is positive. So that is what I want. When I go to the second column, I get negative. So that's not what I want. So I'm staying in this column because that is what I'm interested in. And then in the third column, positive, yes, that is what I want. So now I have my two solutions. Either my number should be less than negative 5, less than or equal to negative 5 over 3. So I have the first one, x is less than or equal to negative 5 over 3. Or now this one here, I say x is greater than 2. I do not put the equal to 2 there. Can somebody tell me why I am not writing it like this? Why am I just writing it like that? It's a question to you guys. I want you to tell me why. Why am I? Because with the first one, I have the equal to. But with this one, I'm just writing it like that without the equal to underneath. Why is that? Nobody wants to guess. Okay, I'll leave it to you to figure out then. Then I can write this. Yes, tell me.
No, ma'am. It's fine.
No, just go ahead. You're probably correct.
Oh no, I was just I was just thinking, what it's unfair that you're not telling us.
It's unfair that you guys are just quiet.
We sorry, ma'am. We sorry.
No, you must tell me. Yes, tell me. Why do you think I'm not putting the equal to next to the 2? But with the negative 5 over 3, I'm putting it there.
My guess is because the 2 was under the fraction.
Okay, but why? What does that? Why does that make a difference?
See, now that I don't know.
Okay. Okay, so I want you to think about it some more. Why? Your idea is
Ma'am. So,
correct. It's correct, but why? Why? Why that? I want you to go and think about it, and then you can tell me. Okay, so if I
yes,
were to draw this on the number line, I would put minus 5 over 3, and then I will put 2 over there. This one, the circle is shaded because from the question I can see that there's the equal to there. So I include it. But then at 2, for some reason my circle is unshaded, and then it goes on like that. And that is the answer. So it has something to do with the fact that it is in the bottom, it's in the denominator. But what exactly? So think about that one, and then you can let me know. And number 7, we have x minus 3 is less than or equal to 4 over x. Okay, and then here what we are also told is that x is greater than 0. Okay, so with this one, what I'm going to do is I'm going to multiply by x on both sides. So when I do that, I have x minus 3, and then the sign doesn't change. So can somebody tell me why am I allowed to multiply here? In the previous one I said don't multiply. I think I even put it in red, big X wrong if you multiply. And this one here, I just went ahead and multiplied. What's the difference here? And then I see the sign hasn't changed, still facing the same way. What's different?
Means because you are not multiplying with a negative number.
Okay, exactly, because we are told that x is greater than 0. X is a positive number. Okay, so when I multiply by x on both sides, I know that x is positive, so I can multiply it on both sides and know for sure that this sign does not change direction. With the previous one, where was it? I didn't know anything about x minus 2, whether it's positive or negative, so I cannot just assume it is positive. Okay, now with this one, there's no assumptions. We are clearly told x is a positive number, so you can go ahead and multiply without any worries. Then you multiply, you get x squared minus 3x. This is less than or equal to 4. Then again, a quadratic inequality, everything on one side, you must have 0 on the other side. So what you have is x squared minus 3x minus 4. This is less than or equal to 0. So you're looking for two numbers that when you multiply them, the answer is negative 4. And when you add the two numbers, the answer is negative 3. So those two numbers, open your bracket. So those two numbers are negative 4 and positive 1. So you put your x, negative 4 and positive 1. Then you solve to get your critical points. You get x minus 4 is equal to 0. This means that x is equal to 4. and then x plus 1 is equal to 0. This means that x is equal to minus 1. So now you have your two critical points. What you do is you draw them on the number line. So you put your number line like that, and then you put your critical points. I have minus 1 and I have 4. You extend the number line to create a table, and then you pick a representative from each of the regions. So the first region, just any number that is less than -1. Let's say -5. In the second region, you want a number that is bigger than -1 but less than 4, so 0, for example. And in the third region, you want a number that is bigger than 4. So the number that is bigger than 4, let's say 12. Then you put your factors. You have x minus 4, x plus 1. And then you'll substitute each of your representatives into the factors. So the first one, minus 5 minus 4, this is negative. Then minus 5 plus 1 is also negative. 0 minus 4, negative. 0 plus 1, positive. 12 minus 4, positive. 12 plus 1, positive. And then the product, you have x minus 4, x plus 1, and then you multiply negative and negative. This gives me positive, negative and positive. This gives me negative, positive and positive. This gives me positive. Then the original question was x squared minus 3, when it's factorized, it was x minus 4, x plus 1. This is less than or equal to 0. So again, you ask yourself, what does less than or equal to 0 mean? This is negative. Okay, so you go to your last column where the product is. So it's this, the last row where your product is, and then you move along the row and you look for where you have a negative sign in that region. In the first region, it's positive. That's not what we want. In the second region, negative. So this is what we want. And then in the third column, this is positive, not what we want. So I'm always looking at the original question in order to determine which of these I want. So it's not that I always want a plus or I always want a negative. What tells me whether I want a positive or a negative is this sign over here. So we say that the middle region is what we want. So your solution will be from -1 to 4. So you have -1 less than or equal to x, which is less than or equal to 4. And then you can also represent this by drawing it. So you have -1 and 4. Then the circle is shaded because of the equal to. The circle is shaded because of the equal to. And then you connect the two with a line like that. So that is how you'll solve those questions. Now let's look at number 2. We have 3x squared plus 3. This is less than or equal to 5 plus 5x. So again, everything with x on one side, everything on one side, 0 on the other side. So we have 3x squared, and I subtract 5x on both sides, and then I also subtract 5 on both sides. So this is -2. x is less than or equal to 0. And if it is not factorized, the first thing you must do is factorize it. So you look for two numbers that when you multiply them, the answer is the same as 3 times negative 2, which is negative 6. And when you add the two numbers, the answer is negative 5. So the two numbers are negative 6 and positive 1. So you open your brackets, you put your variable, and then the two numbers, we said it's negative 6 and positive 1. And then you divide by the coefficient of x squared, which is divide by 3, divide by 3. Then what I have here, this is x minus 2. That's in its simplest form. And then 1 over 3 is in its simplest form, so the 3 will come and multiply the x. Just a moment. Okay, and then plus 1. Is this less than or equal to 0? Then after it's factorized, the next thing is now your critical points. So the critical points, we get them by equating the factors to 0. This means that x is equal to 3. And then the next one, this means x is equal to minus 1 over 3. Then you plot these points on your number line. You see how it divides your number line. So what you have is this. You have negative 1 over 3 and then 2 over there. Okay, you put your factors, x minus 2, and then we have 3x plus 1. Okay, then from here you need to pick representatives. So you need a number in the first region that is less than minus 1 over 3, let's say minus 10. Then in the second region, 0 is always a good representative. And then in the last region, let's pick 10. And what you do is you substitute each of the representatives into the factors, and then you see is your answer positive or negative. So in the first one, negative 10 minus 2, negative. Negative 10 times 3 plus 1, negative. 0 minus 2, negative. 0 times 3 plus 1, positive. And then 10 minus 2, positive. 10 times 3 plus 1, positive. Then in the last row, I have the product. So I have x minus 2, 3x plus 1. And then I work out the product of the signs in my table. So the first one, I have negative times negative. This will give me a positive. The second column, I have negative times positive, which is negative. And then the third column, I have positive and positive, which gives me a positive. Okay, then the original equation now. I had x minus 2, 3x plus 1. This is less than or equal to 0. So I'm not going to pick the one in the middle. That's not what I'm looking for. I'm not picking the first and the third one. That's not what I'm looking for. What I'm looking for, or what I consider, is this over here. Less than or equal to 0. What does less than or equal to 0 mean? Less than or equal to 0 means negative. Okay, so when that is negative, I now go to the last column. So this is what I will now consider. So I'm looking at this row over there. And then I look at the column that has negative. So the first column here, positive, no, that is not what I want. The second one over here, it's negative, yes, that is what I want. The third column here, negative, no, that is, sorry, positive, no, that is not what I want. So the solution will come from, will be numbers between -1/3 and 2. So I can write this down. Solution is that x lies between -1/3 less than or equal to, and sorry, not 1, it's 2, like that. And then I can also represent it on a number line. I put my two numbers, -1/3, and I put 2. On top of 2, the circle is shaded because I have the equal to underneath. On top of there, it's shaded also because I have the equal to sign underneath, and then I connect them using a straight line. So that is how I would do that. So very simple to do, nothing too complicated. Then you can do number 4 as well. Number 4, what we have is x minus 5 squared plus 5, 2x minus 3. This is greater than 2x, x plus 3 minus 6. So this one, it looks more complicated, but there's just a bit of algebra to simplify, and then you'll have a single quadratic inequality. So first thing you should do is this one over here. Multiply out the brackets. So you have x minus 5 times x minus 5. So when you do that, you'll end up with x squared minus 10x plus 25. So how you multiply out the brackets, it's x minus 5 squared. This is x minus 5 times x minus 5. Then the x will multiply, the 5 will multiply, you get x squared minus 5x minus 5x plus 25. Okay, and then the 5x minus 5x minus 5x, that is equal to minus 10x. And then the same thing here, multiply inside, then you will get 10x and minus 15. And then the inequality, okay, faces that way. And then the 2x should multiply. So I have 2x squared plus 6x minus 6. Now on the left hand side, we can see that this minus 10x and 10x will cancel each other. And then 25 minus 15 is just 10. So when I write this, I have x squared plus 10. This is greater than 2x squared plus 6x minus 6. Then you want everything to be on the same side, 0 on the other side, and you want the coefficient of x squared to be positive. So I will subtract x squared on both sides. So here I'll be left with 0. And I have x squared. Then I will be left with 6x by itself. And then I will subtract 10 on both sides. So this is minus 16. And this I can rewrite it as x squared plus 6x minus 16. This is less than 0. So here 0 is the bigger one. That means this one is less than 0. So you can just rewrite it like that. Okay, So we see if it can be factorized by looking for two numbers that when you multiply them, the answer is negative 16, and when you add them, the answer is positive 6. The two numbers are 8 and negative 2. So you open your brackets, you put your x, you put your two numbers, positive 8, negative 2. Okay, so it's factorized, then follow the same procedure. What are your critical points? So your critical points, first one we have x is equal to 0. This means that x is equal to minus 8. Then the second one, x minus 2 is equal to 0. This means that x is equal to 2. So now you have your two critical points. You must plot them on the number line. So you draw your number line like that. Show your critical points. So I have minus 8 there, and then I have 2 over there. Then you extend to form a table. Then you put the first factor, plus 8. You put the second factor, and then you pick representatives. So the first region, any number that is less than negative 10, sorry, less than negative 8, let's say negative 10, and then any number between negative 8 and 2, you can pick half, why not? And then any number bigger than 2, let's say 1000. So the number doesn't matter. What you're looking for is it must be in that region, that's it. And then you substitute each of them here, negative, negative. Then the second one, you get positive. Half plus 8 is 8.5, which is positive. And then half minus 2 is negative. 1000 plus 8 is positive. Then 1000 minus 2 is positive. And then now your product, you have x plus 8, x minus 2, and then you fill this in. Negative times negative is positive, so I'm multiplying because that is what the question says. I must take this one and multiply it with that one. Then what I have in the second one, positive times negative, this is negative. In the third column, positive times positive is positive. Then I write the original equation again, which was this one after I had factorized it. And what I had was that it must be less than 0. So that's what I write, less than 0. So I ask myself, what does this less than 0 mean? Any number that is less than 0 is negative. So I go to my table and I look in the column of the product. So I'm here in this column over there. That's what I'm interested in, this row. Sorry, I'm in the last row, and then I am looking for the column where it is positive, where it is negative. Okay, so that is this one over here. So in the second column, the product over here gives me a positive value. The first column, it gives me positive. I want negative, so it's not that one. The third column gives me a product that is positive. I'm interested in the negative product. So now that I have my solution, I write it down. So the solution to this is that x must be between negative 8. So my solution, x must be between negative 8 and 2. So I don't put the equal to because in the question there is no equal to sign underneath. And then I can also represent this on the number line. I put my two critical points, and then the circles are not shaded because there's no line under the less than sign, and then I connect the two circles like that. So with that, I'm done. I hope that is what you got. Tomorrow we should finish off on this chapter. We look at logarithmic equations, logarithmic inequalities, simple ones, nothing complicated. And then we are back to absolute values. But now we look at absolute values, talking about inequalities and not just equations. Do you have any questions before we call it a day? If there are no questions, then remember this one. Where is it? This one here. You need to tell me why. Where am I getting this from? Why didn't I put the sign there? Because I know there will be a question like this in the test for sure. So you must figure out and tell me, where am I getting this from? Okay, so I'll see you guys tomorrow. Have a good day.